am. So, hello. So I'm very happy to present you the project that is called CRAID. The objective is to improve the access to historical drifter data. CRAID stands for Copernicus Reprocessing of Argos and Iridium Drifters. And next slide, please. Yeah, thank you. So the CRAID project is a global rescue and reprocessing of drifting buoy data. The CRAID dataset contains the metadata of 20,000 drifting buoys that were deployed between 1979 and 2018. So during CRAID phase 1, the data from more than 10,000 drifting buoys deployed between 1997 and 2010 have been delayed mode processed. So this includes a comparison with Copernicus era 5. Okay, thank you. So this delayed mode process includes comparison with Copernicus era 5 reanalysis. The project is continuing in 2022 as CRAID phase 2 and to reprocess the drifting buoys data deployed between 1997 and after 2010. Drifting buoy is a simple instrument, a buoy that is deployed in the ocean. It's about less than 1 meter in diameter. It has a floating anchor, so it measures the current at 15 meter deep, typically, sea temperature and air temperature, and sometimes additional parameters such as air temperature, the surface pressure, or even salinity. And thousands of these floats buoys have been deployed, and so they have a global ocean coverage. So the CRAID deliverables are first, an improved drifting buoy data archive, and then in the contract, we go for fair interfaces to drifting buoys data. So this includes web data discovery for human users and APIs for data discovery, subsetting, download services. So these are machine-to-machine data access. An improved drifting buoy data record. So what do we mean by that? So we mean that missing datasets and parts of the datasets are recovered. So this is typically the data rescue activity. Then we deliver homogeneous and rich metadata and data format, homogeneous quality control and assessment on marine and atmospheric data, match up with Copernicus era data, so the temperatures, ocean and air, atmospheric pressure, and the wind. So here are two examples of improved data records. On this map, the green dots are the data that are available on the international ocean databases. Within CRAID, we recovered additional data that are in black and purple. So in the top, on the 75174 buoy, you have a full Pacific crossing that has been recovered from the CLS Argos original data. And on the bottom graphics, so for buoy 36909, the series is there. The green dots are almost complete, but there are gaps. And you see these gaps that have been filled. The purple data are gaps that have been filled by the CRAID project. So CRAID data and metadata and documentation are published on Zunino with their DOI. So this is the DOI of the project. It complies with fair data rules. So the data is findable. So each DOI published on data site. It is indexed by Google. So it's available on Google dataset search, for instance, and other can harvest it also. It has a link with bibliography and the author's bibliography through ORCID IDs. It is accessible accessible with one-click download and anonymous access. In one click, you get the whole data set, and it provides links to big data services. It is interoperable because we are CF and we comply with CF and CDataNet standards. It's QC documented and has rich metadata, and it is reusable through its CC BY license. And CRED metadata are transmitted to OceanOps team, so IOD WMO. So here is the landing page of the CRED dataset. So as you can see, you have a one-click download for data. The author's ORC ID are available. The data license is human readable and machine readable. We have links for documentation. So this is for human, the NetCDF format, the QC manual. And then for machines, we have links to the dashboard and to APIs, a link to the AirDAP server because data is served by AirDAP also, and a link to Data Charts Explorer, I will show it later, and how to cite statement. Whenever you use this data, please use this citation statement. So in the CRED project, we have a big data infrastructure. In fact, we are using the drifting buoy data are managed on Ifremer big data infrastructure. And so this is a continuum from the CRED project NetCDF files to Parquet files, Cassandra NoSQL database, and Elasticsearch index. So the files, NetCDF files, are the content is transformed into Parquet big data format, and then from there it's indexed in Elasticsearch for data discovery, for metadata, and Cassandra that contains data and metadata and that provide high performance queries. So as an example, the Drifting Buoy's APIs and its dashboard are online. So the dashboard on the left is showing the metadata and the description of the full data set, and it queries the API that is on the left. So the Drifting Buoy's Data Chart Explorer is the same. We have the API that is queried by the interface, and we have the portal querying the API is able to, on the left, perform subsetting with facets, and on the right is showing the data graphics themselves. So who are the targeted users? It's the ocean atmosphere community. CRED high resolution data complements ICOD's buoys data and improve Copernicus C3S era analysis. Ocean community, so temperature are used for satellite calibration and validation, models and reanalysis validation of forcing, and the drifter SST data are assimilated by Copernicus marine modeling centers to constrain or validate the surface fields. So we had in 2021 two updates of the CRED data set. We are preparing the winter 21-22 delivery. So soon you will have 2,000 more buoys, and we expect to complete the global reprocessing by end of 2022. So the CRED dataset delivery is gradually ingested into Copernicus Marine Institute and will flow to other data systems from there, and OceanOps metadata dashboard. We started a machine learning activity on the big data infrastructure, and an example is how can we detect that a drifting buoy did lose its floating anchor? So the question is a drifting buoy drifting at its nominal 15-meter deep current? The solution is to train a model with 3,500 buoys, where we know where an expert provided the information that the anchor was lost, and collocation and match and combination with ERA 5 data and run the model on 500 boys and look at the result if the result of the model is correct. And we had very good results with this training model. So thank you for your attention, and I'll be happy to answer your questions.